Hello students, we will go through a problem based on dual simplex method. So the question is solve the following LPP by dual simplex method. Minimize z equal to 2x1 plus 2x2 plus 4x3 and the constraints are 2x1 plus 3x2 plus 5x3 is greater than equal to 2, 3x1 plus x2 plus 7x3 less than equal to 3, x1 plus 4x2 plus 6x3 less than equal to 5 for all x1, x2, x3 greater than equal to 0. So this is the given question and we have to solve this using dual simplex method. So we will go through the solution. So in the last video we had gone through the steps how to solve dual simplex method. So here we will see it. Okay. So the first step is you have to convert the given objective function into a maximization problem. So if you first you have to just see whether it is a minimization or a maximization. So here they have given it as minimization. So the first step is that you have to convert it into a maximization. So you have to just multiply minus 1. So it will be z equal to minus 2x1 minus 2x2 minus 4x3. Okay. After that, step 2, change the sign from greater than equal to less than equal to the constraints. So as you all know, for a maximization problem, the condition is that all the constraints should be of the form less than or equal to. So here, if you see the first equation doesn't satisfy, so it is of the type greater than equal to. Second and third, they satisfy, they are already in the less than equal to form. So you have to change this first equation. So you have to just multiply minus 1 to the first equation. So it will be minus 2x1 minus 3x2 minus 5x3 less than equal to minus 2. So this is the second step. In this third step, you have to add slack variables to convert the given problem into a standardized form. So we have 3 variables here, so you have to add 3 slack variables. So it will be minus 2x1 minus 3x2 minus 5x3 plus s1 is equal to minus 2. Similarly, you have to add s2 and s3 for the second and third equations. And when you add slack variables to the equations or the constraints, obviously you have to add it to the objective function. So the objective function will be z equal to minus 2x1 minus 2x2 minus 4x3 plus 0 into s1, 0 into s2 and 0 into s3. So this is the third step. Okay. Next, you have to form a iteration table. So this iteration table is similar where you have used for simplex method, solving simplex method using tabular form, big M method. So for all that, and here also it is same. So you have a column, a row of CBI, then basic variable Cj, x1, x2, x3, s1, s2, s3 and the solution column. And this is also called as BI. Okay. So here you just write the values of this thing. Okay, all the equation, that is here minus 2, minus 3, minus 5. You have to just write all the constants, okay, of the variables. So minus 2x1, minus 3x2, minus 5, and here slack variable is 1, 0, 0. Similarly, of the second, it is 3, 1, 7, 0, 1, 0. And the third equation, it is the values are 1, 4, 6, 0, 0 and 1. Okay, and the solution is minus 2, 3 and 5. So it's nothing but here minus 2, 3 and 5. You have to write here in this form. The next step is that you have to find zj value. So how you find this zj value is that just you have to multiply 0 into this plus 0 into 3 plus 0 into 1. So you get 0. Similarly next one, 0 into minus 3, 0 plus 0 into 1, it is 0, 0 into 4, it is 0. Okay, you have to follow this same method to find the zj. Then after that you have to find Cj minus Zj. So again this is nothing but Cj, minus 2 minus 0. So you get minus 2. Then minus 2 minus 0, you get minus 2. Minus 4 minus 0, that you get minus 4. So similarly in this way you find out. Okay. Now the step 4 is that as all Cj minus Zj are either negative or 0, and Bi is negative, the solution is optimal but infeasible. As I have discussed in the last session, in the last video, that there are 3 conditions. So here this is of the form where all Cj minus Zj are either negative. See, if you can see here, it is negative or 0. Okay, and Bi is negative. See here, if you can see, this is Bi, that is solution column, you have a negative value. So it is said that the solution is optimal but infeasible. Okay, so you select this minus 2. Okay, as Bi is equal to minus 2, the first row in the is the key row and S1 is the outgoing variable or the leaving variable. So this is the key row. So you have to just find out the most negative from this column. Okay, so this is the, so I'll mark it here. This is the key row or the pivot row. Okay,